Greetings, everyone. I'm Benjamin Kitambo, research engineer at the Centre National de la Recherche Scientifique, CNRS, in Toulouse, France, and also a research assistant at the Congo Basin Water Resource Research Center, CREBAC, in Kinshasa, DR Congo. My presentation is titled Long-Term Spatial-Temporal Variation of Surface Water Storage from Space over 24 years. To begin, we know that freshwater is crucial to human life, but human knowledge about the spatial and temporal dynamics of the surface freshwater variation is limited, particularly in Africa, where we still have a poor understanding of the hydrology of the major river basin. This limited knowledge prevents the development of water resources management. A key hydrological variable to discuss is surface water storage, which is a precious resource in terms of biodiversity, ecology, water management, and economics. Surface water storage plays a key role in the climate system and water resources variability, as well as in the variability of the total water storage in the tropics. Therefore, this hydrological variable, surface water storage, is an indicator of the current climate change. However, the global land surface model output has not yet well estimated surface water storage, and the current knowledge about the spatial temporal variability of the surface water storage is still poor regionally and globally. So here we are presenting the ongoing efforts to estimate the surface water storage from Earth observation. This ongoing effort has led us to a scientific question. What is the spatial temporal variability of surface water storage and the global scale from space? We will present the case of some major African river basin. To answer to this question, a trove of Earth observation is used that include Global Inundation Extent from Multi-Satellite datasets, GIEMS-2, digital elevation model data, and in situ database. The methodology used to estimate the surface water storage is an hypsometric curves approach that combines surface water extent from GIEMS-2 with a digital elevation model. For each pixel of surface water extent, we compute the hypsometric curves that provide the relationship between elevation and the surface water extent, which allow us to estimate the surface water storage. Here we present for the first time the spatial variability of the mean surface water storage over Africa. We can observe that this dataset depicts the large floodplain and wetlands that are the particular ecosystem of the major African river basin. Now we present the temporal variability within the Niger River Basin over 24 years. Figure A presents the raw series of the datasets. Figure B displays the deseasonalized anomaly, highlighting extreme events in terms of drought and flood, modulated by local and regional variability such as ENSO and El Nino events. Figure C shows the annual cycle of the surface water storage datasets. To gain confidence with our datasets, we also used an independent dataset of discharge and rainfall to evaluate our datasets. Looking at the Congo River Basin, Figure B shows how this dataset depicts the large flood that occurred in 1998 and the major drought that occurred in 2005 and 2006. So this dataset also provides the opportunity to characterize especially extreme events. This slide shows an example of the spatial signature of the major droughts in the Congo River that occurred in 2005 and 2006. In conclusion, Earth observation dataset have allowed us to estimate the monthly satellite-derived surface water storage over 24 years. These newly estimated datasets underline that surface water storage is modulated by local and regional variability by highlighting also some hydrological patterns. This dataset is an important source of information in support of water resources management. In perspective, this dataset can enable us to deepen the understanding of extreme events in conjunction with climate variability. It also helps the estimation of the contribution of each subsurface storage component to total water storage variability. And finally, it can allow us to derive a long-term groundwater variation in combination to GRACE and GRACE follow-on satellite. I'm ending my presentation by saying thank you to remote sensing and thank you to you all for your attention. Thank you.